This is activity 2, dilations, in lesson 5, which is entitled More Dilations. So activity 2 is just titled Dilations. Actually, this is what's called an info gap activity, in that there is a problem card that one student gets, and the other student, if you work in pairs, gets the data card. And there are 2 of these problems. So there are 2 problem cards and 2 data cards. And the student with the problem card is supposed to ask questions of the student with the data card, get those answers, and then perform that dilation on this grid based on that information that they get. And so you need 3 pieces of information to dilate an image. You need to know what the center of dilation is. You need to know what the scale factor is. And this scale factor in this problem is 1/3. I think it says 3/5, if I remember right, on one of the images that's downloaded. But the scale factor is actually 1/3. So you need to know the center of dilation. You need to know the coordinates of the points, and you need to know the scale factor. So you need 3 pieces of data to dilate an image. So the coordinates are A is at 0, 6, I is at 0, -6. So that's 0 on the x-axis, so it's not moving away from the y-axis, and that's 6 up or 6 down along the y-axis. And F and D are 6, 0 or -6, 0. So those are along the along the x-axis. They're not moving up and down at all. They're just moving 6 units out. 6 units in the positive direction on the x-axis and 6 units in the negative direction on the y-axis. And the center of dilation is going to be the origin on the coordinate graph. It's just, it's labeled point B, and it's at 0, 0. So that is the origin. And the scale factor, as I mentioned earlier, is 1/3. So this is what the answer looks like. So before I show you how I got there, I just want to show you the answer so you have this in mind as you think about this. But this is what you should end up with if you're doing this the way it's designed by the authors. All right, so your partner gives you these points. You're supposed to ask for them, and there's actually extra points that your partner has. And I don't know if your partner knows what the problem is. Your partner might not know what the problem is. So you can't just ask for, tell me all the points. I have to look at that. Let's go back here just for a second. Data card, the partner doesn't know what the figure is. So through discovery, as a person solving the problem, you're supposed to get the coordinates for A, F, I, and D. And then your task is to use point B, 0, 0, as the center of dilation, and make these lengths 1/3 the size. So a dilation factor of 1/3. So if each of these lengths go out 6 units, so this is 6 units this way, 6 units, 6 units in the negative direction, 6 units in the negative direction along the x-axis. Well, what's 1/3 of 6? 1/3 of 6 is 2. 6 divided by 3 is equal to 2, or 6/3 is equal to 2. So then you place the point. Now it has to be in a straight line from the center of dilation to that point. These are each points at the vertices of the figure, of the polygon. So the center of dilation is or the point that gets dilated is on a straight line from the center of dilation to that point. So it has to be on a straight line, so they're placed here at -2, +2, +2, and -2. Then you connect those points, and you get the smaller image. So each of these lengths are 1/3 these lengths. So it's a dilation of 1/3. And each of these lengths are parallel. So in dilations, the similar image, what gets the result of the dilation, each of those lengths are parallel to the original lengths. But in this case, they're 1/3 the length, 1/3 the size. But the angles remain congruent. The angles remain the same. So for this figure, all the angles are 90 degrees. This is the next one. This is problem number 2. And this is actually the answer. Once again, you're supposed to dilate a polygon that is O, N, P, and Q. So remember, you have to get the coordinates of those points, ask about the dilation factor, and the center of dilation. Well, the center of dilation is P, and the dilation factor is actually 5/4. So each of these lengths, the red lengths, can't see them covered up, get increased, get multiplied by 5/4. So that's actually increased by 1/4 of the unit length of 1 unit. So it's 5/4. And this length out in this direction is 5/4 of the original length. These lengths are 5/4 of the original length. And this length is 5/4 of the original length. So you have to figure out how you're going to multiply by 5/4 and figure out where those points go. Well, the first one, the dilation of O, and the center of dilation is P, that's just moving out 1 more fourth. So 5/4 means 1 more fourth than 2 units, actually. So this is, 4 units. So 5/4, so this is 1/4, 2/4, 3/4, 4/4, and then 5/4 means it's 1 more fourth tacked on to the end. So 5/4 times 4 is equal to 5. So this is 5 units out. So to get these 2 points, a little bit harder because they're on a slant or on an angle. So what you can do is go down 1 unit and then scale that length up 5/4. And then just go back up 1 unit, or we'll figure out which direction to go in just a moment. If I go down 1 unit and just count, so this is 1, 2, 3, 4, 5, 6 to get to these 2 points. All right, so what's 5/4 of 6? You have to take 6 and divide it by 4. So 6 divided by 4 is 1 5/10. And then you need 5 of those 1 5/10. So you need 5/4. So this is 1/4, 1 5/10. This is 2/4, which would be 3 units. This is 3/4, which would be 4.5 units. This is 4/4, which would be the 6 units. And then this is an additional 1.5 units, or 1 5/10. So along the x-axis, you're going to go out to here. And then how far are you going to go along the y-axis? This way, and along the y-axis this way. So I know I'm going to get out to here. So if I were moving along this x-axis, I know I'm going to get to here. I just have to figure out how far to go up in the y direction and down in the y direction. And that answer is 5/4 of 2. So this length is 2 units. So what's 5/4 of 2? Well, 2 divided by 4 is 1/2, 2/4. So this is 1/2 unit, or 1/4. This is 2/2, or 2/4 of this length. This is 3/4 of this length of the 2 units. This is 4/4 of the 2 units. And then you have to add an additional fourth. So the answer, 5/4 of 2, is actually 2 1/4 units. So it's 1/4, 2/4, 3/4, 4/4, and 5/4. So 5/4 of 2 is 2 1/2. I show that up here. 5/4 of 2. So 2 times 5 is 10. 10 divided by 4 is 2 1/2. All right, so from this point, this is the 5/4 of 6, and then you go up 5/4 of 2, and you end up right here. So then you draw a line from the center of dilation through the original vertex, and it's going to continue through the scaled, or the dilated vertex. Do the same thing down here. So this goes through the original vertex and the scaled vertex. Same thing down here through the original vertex and the scaled vertex. So notice that this length is 7.5. It's 1.5 units more than 6, and this length is 2.5. It's a half of a unit more than 2. This is 2.5 units, and this is 7.5 units. So you just have to work through with the fractions to get used to that. And you get these points and connect them, and you get this scaled image. So this image, each of these lengths are 5/4 the original length. Notice that each of the lengths are also parallel to its corresponding length. So this length is parallel to this length parallel to this length. These lengths map right on top of each other, so they're obviously parallel to each other. And finally, the angles are always congruent. So these angles map right on top of each other, but this angle here is congruent to this angle is congruent to this angle is congruent or the same as this angle. And actually the angle within this image is this angle right here. It's greater than 180 degrees. And that's the same as this angle. It's greater than 180 degrees. All right, so this is activity 2. It's an info gap on dilations from lesson 5.